تفضل أستاذة خديجة.
السلام عليكم ورحمة الله وبركاته. ويتجدد بنا اللقاء بأمسية جديدة مع إدارة الشؤون الأكاديمية والتدريب بصحة الطائف بالتعاون مع مجمع الملك فيصل الطبي ممثلة بقسم المختبر عن دورة تتكلم عن جودة في المختبرات الطبية بعنوان Levigenic Charts and وستغراد Malt Rules. اللقاء بقيادة طبيب أخصائي مختبر الدكتور سيد نديم. المايك is yours دكتور سيد.
Thank you so much. Assalamu alaikum wa rahmatullahi wa barakatuh. This is Dr. Syed Nadeem Ahmed Kirmani from King Faisal Medical College. I am specialist of biochemistry. Today, we will have a talk about Levigenic quality charts and Westgard rules. First of all, let me begin with the term quality. What does quality mean? Quality is described as an attribute or a characteristic of someone or something. So we are aware that it means something which is very good in nature. Similarly, we want that we should have a good quality in our laboratory. So today we will discuss how to achieve that. First of all, we talk about the history of the quality. In the 1920s, Edward Deming published a list of quality control rules to reduce variability in production. At the same time, Walter Shewhart devised quality improvement methods such as control charts and Plan, Do, Study, Act. He is known as the father of modern quality. In the 1950s, Esther Bill Roberts introduced the exponentially weighted moving average chart, and Stanley Lever and Elmer Jennings adapted the Shewhart control charts for chemicals. Now we move on to a very important heading in this chapter, that is calibration. What does calibration mean? It is the relation between instrument signal, which is plotted on the y-axis, against the concentration of the analyte, which is plotted on the x-axis. This relationship is established by measurement of samples with known quantity of the analyte, also known as calibrators. The calibrators differ from reference standards in their preparation. Calibrators are prepared in the same matrix, that is serum or plasma or whole blood, as that of the analyte to be measured, whereas the reference standards are solutions of pure chemical substances. We have several types of calibrations. The most common is 2-point calibration, which is done frequently in all chemical laboratories around the world. This 2-point calibration simply means that you use a blank, which should be indicating 0, and we'll have our questions and answers at a later stage of the Rahman. Please bear with me. So the 2-point calibration is important for chemical substances such as glucose, the most commonly done test. So in this situation, you have a linear chart. A linear chart means a straight line starting from 0 to the calibrator, which is maybe 100 or 200, depending on different companies. So you have a 2-point calibration, and This calibration is most commonly followed in our laboratories. Now we will go to the quality controls. We'll have the question and answers at the end. Please note down the questions that you want me to answer, and we'll have a session based only on question and answers. The quality controls are chemical substances used for quality control purposes. They are available in aliquot or vial forms. They should have minimal variation in its assay over an extended period of time, and consecutive measurements should produce similar results unless there is an analytical error. What are Levigenic charts? You must have heard it a lot of times. Levigenic charts, LJ charts are commonly being talked about. Let us see what are these Levigenic charts. As I discussed in the history, Levy and Jennings were the ones who devised quality control methods based on charts. The control charts or Levigenic charts are used to compare observed values of control materials with their known values. The chart consists of observed results plotted against the time of processing in a simple graphical manner. The known values appear as limits of acceptance, or upper and lower control limits. When the observed values fall within the control limits, it indicates that the test method is performing properly. On the other hand, when some observed values fall outside the control limit, it indicates error in the process. We'll define these errors and discuss how to correct this at a later stage. First of all, we need to find out what is the mean. What do you mean by mean? The mean simply is the average of several readings. The control limits are calculated from the mean and the standard deviation. How to calculate the mean? You take the number of observed values and the sum of the observed values, divide the sum of observed values by the number of observed values, and you get the mean. Then how to calculate the standard deviation? As you can see, the standard deviation is calculated by this formula. It appears a bit complicated and mathematical, but it's a simple formula in the sense that you are subtracting the observed result from the mean, and you are squaring that, the whole differences, and you are dividing by the number of values, and then you will take a square root of all these values. Usually in the machines we have the software wherein you don't need to do all these calculations. It is done automatically by the machine. The values are fed in the system from the company. It can be downloaded, and once the values are there, you need not worry. But in case you want to know the mathematics behind it, you can always refer to these formulas for the mean and for standard deviation. After this, we will see how to plot the Levigenic charts. We will plot the control values on the y-axis, that is the vertical line, and the time will be on the x-axis or horizontal line. Usually, 20 values are plotted, and from there you can calculate the mean in case you want to calculate your own mean and standard deviation. This is the common process. Take 20 observations, calculate the mean, and calculate the standard deviation, and you can plot this on a graph. And these charts provide an easy to review, a visual display to assess the test method. That means Just a glance at the screen of the Levigenic chart will tell you if your method is performing properly or not. To interpret this variety of data, we use the Westgard rules. This is an example of a normal Levigenic chart where you can see the upper control limit in red and the lower control limit also in the red, and a dotted line in the center indicating the mean. The observations, the values which we find from the machine on a daily basis are plotted, and you can see some values are near to the mean, some are away from the mean, but all the values should fall between the upper and the lower control limits. This tells you about the problem in accuracy, either a trend or a shift. If the results, if your values tend to drift away from the mean, it is a danger sign. A trend, you can see in the middle, the trend is that the values are going up. A shift means the
Are you still with us? Dr. Saeed?
So we now come to the Westgard rules.
Did
The first
you hear
one,
me?
yes,
Did you
I
hear
can
me?
hear. Yes, I can hear you.
Your connection is poor. I just recommended to you turn off your video because your connection is very poor.
Okay.
You can go to the start video and you can stop video. The icon behind mute. Dr. Saeed, did you hear me? Dr. Saeed? I think Dr. Saeed have a connection issue.
Yes, hello.
Yeah, you
It's
can
not
continue.
responding the program.
Okay, no worries. You can continue. We can hear you very well.
Okay. So, yes. I was talking about the Westgard rules. As you can see, the
Dr. Saeed?
the data before we can progress further.
Can you please repeat your saying, because Your voice is not clear.
Okay, can you hear me clearly now?
Yeah, I can hear you now, but there's something in the, you have to remove this one. Is better? Yeah, keep going.
Now you can see the screen clearly. Okay, so I was referring to the ones to ST or warning rule, wherein one value of the control, it can be either level 1 or level 2 if you are running 2 levels of controls. Just a single value falling outside 2 standard deviation, either plus or minus. It is a 1 to ST or a warning. In case of this condition, you will refer to the control chart and you see that there is need for further check of the system. This is a random error which is unpredictable and can happen at any time, and there are several causes for this. And to surmise it, to say in short, this gives you a warning that you need to check your system and you must repeat the same level of the control, and if your second run or your rerun is within 2 standard deviation, you can continue with the process. If not, what is the indication? 2 standard deviation, 2 times 2 standard deviation. As you can see the red points below minus 2s. If you rerun and you find a similar standard deviation 2, standard deviation minus as the first, or 2 standard deviation plus as the first, it should be on the same side of the graph. If you have 2 standard deviation, that means you have an error in the system, and this is no more a random error, this is a systematic error. You have to reject your measurements if you have a plus 2s or minus 2s control limit exceeded by 2 consecutive runs. As opposed to this, if you have a single reading beyond 3 standard deviation, plus or minus, it's a systematic error and you cannot accept this run. You have to reject it. You have to take corrective action, and only once you have a corrected quality control, you can process your samples and release the results. As you can see in this chart, the 3 standard deviation minus 3 standard deviation in red is followed by another result which is just above 1 standard deviation plus. That means it has been corrected. The 1,3s, as I discussed, is a most commonly used in a Levigenic chart when the control limits are set as 3s plus or 3s minus. When you have a single measurement out of control, it indicates that there is systematic error and you need to take up corrective action. The next multi-rule is a 4-1-ST. A 4-1-ST means the 4 consecutive results are beyond 1 standard deviation, but within 2 standard deviation. They can be either plus or minus. 4 consecutive results falling on the same side of the mean beyond 1 standard deviation and within 2 standard deviations. This means that there is an error. So you will need correction for this. What is this? This is 2 results, consecutive results, which are beyond 2 standard deviation, but on the opposite side of each other. a +2 standard deviation and a -2 standard deviation. It is called R4S. In case you see an R4S, this is also, yes, hello.
There's a square in the screen. Could you please remove it, or can just, yeah, no, not yet. Go to the Zoom. Yeah, it's gone. It's all right. Keep going.
Okay. R4S, as you can see, is 2 consecutive results. The 2 consecutive results in red are R4S. And R4S is not an acceptable result. It is not random error. It's a systematic error. The 2 consecutive results more than 2 standard deviation on opposite sides of the mean indicate an error in the system, and you need to take a proper corrective action for this. We will discuss the random errors and the systematic errors once again. A random error is totally unpredictable, and it cannot be predicted, as the word suggests, unpredictable. You don't know when it will happen and in which direction. As opposed to this, a systematic error is predictable and it usually is repeatable. That means that when you process the same level of control, it will give a similar result from the previous one. Like 2 standard deviations or 4 1s, these are systematic errors which will continue to recur. Whereas a random error causes imprecision. What is precision and what is accuracy? This needs to be discussed first of all. Accuracy means trueness of the result being very near to the actual value means accurate result. Precision means that you will repeat the test as many times and you will get a similar result. That means a precision. In case you have different results for the same material, it may be a sample or it may be a control material. When you process it over different periods of time in the same machine with the same chemicals, if you don't get same results, it means the system is imprecise. Imprecision is not a desirable property. Similarly, inaccuracy or false results not near to the true result are undesirable. So we have to take care of both imprecision as well as inaccuracy. So first of all, you have to review your results. When you start your work, you need to review your results from the quality control that has been run in the previous shift or just at the start of the shift. If you find a random error, you need to repeat that particular level of control, and if your repeat or rerun is corrected, that means it falls within 2 standard deviations. That means your error has been corrected. In case you see a 3 standard deviation, you will immediately reject that run. Or if you have 2 standard deviations, also you will reject the run. 4 1s, R4s, 10x, these are different types of errors which have to be seen over a longer period of time, and you have to take corrective action in that situation also. So what are the corrective actions that you're supposed to do? First of all, you need to make sure that your reagent is not deteriorated. You must look at your reagent, whether its shelf life has been exceeded or not. Secondly, you will look at your calibrators, when was the last calibration done? Was it successful or not successful? And the preparation of the calibration is also important. Has the calibrator been prepared properly? Is it belonging to the same lot as in the system, as in the machine? Similarly, you also have to look at the controls in the same manner. The controls must match in the lot number in the system, in the machine, and their preparation should have been done properly, and the shelf life should not be expired. Storage is also an important issue. Has the control been stored properly or not? Once you make sure about all these features, you can perform a calibration, and once the calibration is successful, you will rerun the controls, and that should solve your problem. In case this doesn't solve your issue, the problem is still persistent, you have to look at bigger picture. Maybe there is an error in the machine. For example, your lamp is blown out. So how do you know whether the problem is in a system, in the machine, or it belongs to the reagent? You must look at several other features. That means you have multi-sample controls which you should look into. If you have only one particular reagent giving you a bad result, that means the system is working fine except for that particular test. Or if you have several failed QC for different tests for different reagents, it indicates that there is a mechanical problem in the probe, the reaction cells, in the lamp, and you must do your troubleshooting according to that. Let us go to the question and answers if you are ready with the question and answers.
Keep going, Doctor. There's still no any questions from the attendants.
Okay. There were some raised hands in between, that's why. No questions. Yeah. Can I switch off and switch on? Maybe that will solve this issue because my screen is not responding properly.
It's okay. Dr. Said?
Yes, I can. I am back online again.
Yeah, you can share your screen now. It's better to stop your video because your connection is too poor.
Okay. Can you hear me now?
Yep.
So there are any questions? Because
Not yet.
I have completed all the slides.
All right. Well, we didn't have actually any questions right now.
Okay.
I want to ask Dr. Said, can you listen me?
Yes, I can hear you clearly.
Yeah, I want to ask for types of quality control.
Yes. The types of quality control, it's a good question. We have two different types of quality controls. One is a normal and one is abnormal. This is the common in chemistry and hormone section. Similarly, you can classify on the type of the material that we are using. This was based on the values. The other classification is whether the type of substance is a powder or it's a ready-made solution. So you can have vials or powders which you can add water or any other solvent which is provided to make a solution which can be used for the quality control purpose. I hope that satisfies you.
Yes. And another question, how to manage quality control materials?
Okay, the quality control material is provided with the instructions. What is the temperature that is needed during transportation? What is the temperature for storing the control? Is it supposed to be kept at room temperature or cold or in frozen section? Similarly, there is also a need to protect it from the light, especially for chemistry testing. And you have to follow the manufacturer's instructions while preparing the solution and while storing it. It's always preferable to make aliquots so that once you prepare a standard solution as a quality control material, you can have different aliquots which you can freeze and take out when needed. If you prepare and keep in a single bottle, there's more likelihood of it being degraded over a period of time. So that's how you prepare and store the quality control material. And last and most important point to remember is when you are processing the quality control material, it must be brought to room temperature before you process it. And if it is frozen, you take it out and keep in a water bath, or you can, if you have sufficient time, you can leave it in a drawer or a bench top, protected from light till it reaches room temperature. A preferable method would be to keep in a water bath, which is at room temperature. And once the material comes to room temperature, you can process it. And a very, very important issue is freezing and thawing. Once you have a substance which is frozen and you thaw it, that means you bring it to room temperature, please do not return it back to the freezer unless it is clearly stated in the manufacturer's instructions. I hope that satisfies your question.
Right, I have a question.
Systemic errors. How we detected errors?
Errors, yes.
Errors. Yeah.
Yeah, we have two types of errors, as I discussed previously, random and systematic errors. A
Yes.
random error, by the name itself, it suggests that it can happen at any time by chance. That doesn't indicate a problem in the system. A random error is only a warning. It can occur due to a bubble in the solution, or during the processing, maybe there is a temporary loss of power, or there can be a fading of the lamp for a short, very, very short duration of time. So random errors are only a warning. Systematic errors, on the other hand, are serious issues. That means that there is something wrong in your system. You need to look at it carefully. We have to examine the reagent, the machine, the calibrator, and the quality control material. What do you examine in the machine? You examine the components, as in the sampler or the reagent pipettes, the reagent itself, the reaction cells, the photometer lamp, or if it is not based on photometry, the measuring chamber in case of chemiluminescence assay. So these are important factors to be seen in the machine. Then in the calibration, you need to look at when was the last calibration performed, if it was successful or not. In case it was performed a long time ago, the machine should be giving you a suggestion that there's a need for recalibrating. Even if it does not give you an alarm, you should recalibrate in case of a systematic error. You have to first rule out machine errors. If machine errors are ruled out, then you must look at the calibration errors. Solve the calibration issues, and if still there is a issue, there is a problem, you need to look at the reagent. Maybe you need to change the reagent. That's how you solve the systematic errors.
Another question in non-statistic tools for quality control. Can you talk for type of check sheets?
Statistical sheets.
Yeah.
Okay. In the statistical sheets, the Levigenic is the most commonly used, which is a simple graph where you see two different levels of controls, normal control and a pathological control. There are different methods of looking at it. You may define it as a 3 standard deviation or a 2 standard deviation, and accordingly, the labs tend to process their samples. If they have a violation of 3 standard deviation, only then they will correct. Whereas some other laboratories look at 2 standard deviations as their cutoff point. So that's how you look at in your Levigenic graphs. Similarly, you have a multi-rule wherein you look at the overall graph, not just the daily run. You look at the overall graph. If you can find any trends, that means your system is gradually deteriorating. You need to look at a trend, or you need to look at shifts in the mean, and you will solve according to that issue.
Dr. Said, I want to ask what Levigenic chart important?
Levigenic charts, the importance is that it's an easy tool to look at, and you can gauge whether your system is processing properly or not. And just by a visual examination, you don't even need to look at the numbers. Just look at the screen, and if you see your controls within the 2 standard deviation, you can say a go ahead green signal for processing the run of batch or a random sample also. So Levigenic charts provide you with a visual display. Even a simple technician who doesn't have much experience, when he opens the system and sees the Levigenic chart, and he sees that the graph is within the 2 standard deviations, he can judge that the system is working fine. So that's the advantage of the Levigenic chart.
How do you make a Levigenic chart?
You can make a Levigenic chart by processing the samples, the quality control material, I mean to say the quality control material, and you plot it in a graphical manner with a mean and standard deviation. To calculate the mean, you should have the company provided mean, or you can get your own mean by processing the control material 20 times and then combining all these results mathematically and dividing by 20. So that will give you the mean, and you have a formula for deriving the standard deviation, wherein you will subtract the observation from the mean and make a sum of all these subtractions and then divide by the number of readings, and you have a square root of all these results, which provides you the standard deviation. So once you have a standard deviation and a mean, you will draw different lines indicating 1 standard deviation plus and minus, and 2 standard deviation and 3 standard deviation. You will plot the observations, the results of your daily controls on this graph, and your Levigenic chart is ready. Usually in the auto analyzers, this is an automatic process. You don't need to draw it. The machine will automatically draw it, and you can just glance at it and find out whether your graph is correct or not.
Yes, doctor. How do you aggregate a Levigenic chart in Excel?
How to make it in the Excel sheet?
Yeah.
Okay. In the Excel sheet, the same process will be followed. You have a vertical line and you have a horizontal line. The horizontal line will be equal durations of time. For example, if you have an 8-hourly shift and you are processing the controls in each shift, you will have 3 different times in a day. So you will plot on the horizontal line the time, whereas the observations, the values which you derive from your daily run of the control, will be plotted on the vertical line. So that's how you can chart the Levigenics graph.
Yes. Okay, doctor, how many Westgard rules are there?
There are several Westgard rules, as I spoke previously. The first rule is 1-2 standard deviation. This 1-2 standard deviation is a warning. You have 2-2 standard deviations. This is a systematic error. You have a 1-3 standard deviation, either plus or minus. You have 4-1 standard deviations. This must be consecutive results on the same side of the mean. Then you have R4S, where 2 consecutive results are in the opposite direction. You have first result may be more than 2 standard deviation plus, and the second result or the second level, it can be across material also. Yani 1-2 standard deviation for the normal control and 1-2 standard deviation in the minus for the abnormal control. This is R4S. Then you have a 10x, wherein 10 consecutive readings fall above or below the mean. This has to be within 2 standard deviation, because if it increases the 2 standard deviation, it will not be 10x anymore. So 10 consecutive readings falling on the same side of the mean, above or below the mean. This is 10x. So these are the different Westgard multi-rules that have to be examined and followed.
Yes, Doctor. A person who has a question can raise the hand, please. هل في مداخلة؟ في أحد حاب يشارك في المناقشة؟
أتوقع في سؤال في Q&A للدكتور.
Yes.
There's a question from Leila in Q&A.
I don't see any question and answers. Can you ask me the question, because I don't see in my screen?
It's available now in the chat.
Yes, can you repeat the question, please?
Yes, it's about the monthly QC. When we find the two consecutive points, 1.2s on 2 different days, we can report as a 2s or not.
Yes, definitely. If two consecutive results are more than 2 standard deviation, it is a systematic error. It can be on either day. Most likely, it is 2 different shifts. But anyhow, if you have 2 consecutive results on the chart, which is more than 2 standard deviation, it is considered as 2 to ST. Okay, I have a question from Jamal. 1-3 standard deviation is random or systematic error? Okay. It is a systematic error, and we will reject the run because 3 standard deviation is beyond the acceptable limits. Okay, I have a question from Muhammad Radwan. Lab established SDs are very narrow and give a lot of false rejections. Okay. That is true, yes. The question was that lab standard deviations are very narrow and give rise to a lot of errors. Do we need to solve all these or not? You have to go to the Westgard rules in this case. You must follow the Westgard rules.
We are still waiting for your question.
Yes.
Please, if you have any question, please just type it on Q&A icon. There's any relationship between the Levigenics and sigma level, what is available in approach of Six Sigma? I think it's very close, right, Dr. Said?
Well, Six Sigma is beyond the discussion of our present topic, because
Yeah.
Six Sigma is more to do with overall quality management, not just lab quality management.
Yep.
It will cover a lot of other issues along with this. Here we are focusing only on our own laboratory controls. We
Yeah.
are not taking into consideration pre-analytical variables which are to be considered in a Six Sigma form of quality assessment. As we see that Six Sigma is a big and vast issue, and it's got more to do with the industrial sector rather than a hospital. Although nowadays a hospital is also considered to be an industry in many countries. But our present discussion is limited to the laboratory quality control and how to manage it on a daily basis or a monthly basis.
Yeah. This is a question from the attendance in the Q&A in your absence, by the way.
Yes.
All right. There's another question from Gasim.
There's difference between quality control, calibrator.
Your voice, Doc.
Yes, I said this question says that there is is there a difference between quality control and calibrators? And if yes, what is the difference? This is a good question. Calibrator is a fixed value which is used to calibrate the machine to give you a graph on the basis of which you will assess your daily samples and controls. So calibrator has a fixed value. You have a known quantity of the analyte. The analyte means the substance which is being tested. So the control does not have a fixed value. The control is in the same matrix as the substance that you are using for testing, like blood or serum or plasma or urine. And the quality control has a range. It doesn't have a single fixed value as opposed to calibrators. And by the way, if you intend to interchange the control and the calibrator, it is not recommended by any good quality practitioner. Please don't use the control as a calibrator or a calibrator as a control. So if you have heard me, Mr. Qasim, Muhammad Qasim, the difference between quality control and calibrators, I will repeat once again. The difference between quality control and calibrator is that the quality control does not have a fixed result, fixed value. It has a variable result, whereas a calibrator has a fixed value. The quality control material is processed based on the calibrator. The calibrator will be used to fix a definite point in the graph, wherein you will derive a line, a linear equation, which is used to assess the samples and the controls. And the controls and calibrators are not interchangeable. That means you do not use quality control material in place of calibrators, and you do not use calibrators in place of quality control material. I hope that answers your question. Okay, I have another question from Walid Al-Mursi. If I accept 4-1S chart, this means no role for 10x. Walid, don't be confused between 4-1S and 10x. 4-1S means 4 consecutive results which are greater than 1 standard deviation, whereas a 10x need not be more than 1 standard deviation. It can be within 1 standard deviation, but yes, I will repeat that, Walid. 4-1 standard, it means 4 consecutive results which are greater than 1 standard deviation. it has to be on the same side of the graph, and it has to be 4 consecutive results. It can be across 2 different materials, 2 different quality control materials, but it has to be greater than 1 standard deviation. Whereas 10x means 10 consecutive results just above or below the mean. It can be within 1 standard deviation, but it is only 10 consecutive results above or below the mean. We have another question from Muhammad Radwan, which says, can we establish a mean and standard deviation if some QC point are outside the manufacturer's reference interval? No, we cannot go beyond the reference interval given by the manufacturer. We can establish our own mean and standard deviation, but it has to be within the manufacturer's reference interval. Okay. Any more questions?
Until now, we didn't have all questions answered. Thank you very much, Dr. Saeed. We're still waiting for more questions.
Okay.
Please don't be hesitate. Just type your question.
هل في مداخلة؟
كيف يا أستاذ خديجة؟
أستاذ طارق.
اتفضلي.
أقول هل في مداخلة؟ في حاب أحد يشارك؟
ما
أتوقع
في حد
أستاذ عبد الله معانا، أستاذ عبد الله بعلي. ما حد رافع يده؟
أستاذ عبد الله بعلي بحاول أشوفه أنا في الاتندنس. عبد الله ما هو موجود معنا. إذا كان موجود خليه يرفع يده.
I have another question from Walid Al-Mursi.
Yeah, keep going.
It says, what is the expected in 4.1s as systematic errors? If I understand it correctly, you mean to say a 4.1 standard is considered as systematic error? Yes, my dear, it is a systematic error. And you have to look at your reagent and calibrator and control and the system as a whole. So this is not a warning, it is a systematic error, not a random error. One more important issue that you must remember is that the systematic errors recur as many times as you perform without a corrective action. If you repeat and repeat the control, you will get the same type of error, or even if you are not repeating this, the control material, if you ignore a systematic error and keep performing your tests, all your results will have a similar bias from the mean, either positive or negative, depending on your error. If it was a 4 minus 1s or 4 plus 1s, your results will be similarly high or low. So it is not recommended to ignore a 4.1 standard.
Dr. Said, can you talk
Yes.
for type for Pareto chart?
Pareto charts, okay. The Pareto charts are not recommended nowadays. This was a previous system where you would have a cumulative sum of the mean, and these are now outdated. We are into the age of the Levigenic chart, and we are not following the Pareto charts. It is only of historical significance.
Dr. Saeed, are you still with us?
Yes, I can hear you.
All right. Okay, I think this is the end of the course today. There's no more questions. We're still waiting for any questions or any inquiries you want to ask Dr. Saeed Nadeem. He's still here to answering your questions. Okay, I think it's a time to closing this session. There's a question, I think. Yes, there's another question from Muhammad Radwan.
Yes, it says, so Muhammad Radwan's question is, how many days I should use the old and new QC lot in parallel? If I understand properly, you mean to say that you want to perform a comparison. Well, the comparison is only recommended when you have a change in the lot of reagent. It's not recommended to compare the old and new QC lot in parallel. And if in case you want to compare, it should be done only for establishing the mean and the standard deviation in case you don't have a specified mean, or if you have changed your system and your measuring method has changed, you can use a old and new QC lot in parallel. I have another question from Walid Al Mursi. What is the difference between 2 standard and 4 standard? Okay, Walid, you are confused about R4S, I believe. 2 standard deviation, it is very clear that it is 2 results which are above or below 2 standard deviation on the same side, whereas an R4S means 2 consecutive results which are above 2 standard deviation and below 2 standard deviation. If you will see the graph that I have presented, you will find R4S, one result is greater than plus 2 standard deviation, and the second result is greater than minus 2 standard deviation. That is R4S. Whereas a 2 standard deviation means 2 consecutive results plus 2 standard deviation, or 2 consecutive results greater than minus 2 standard deviation, below 2 standard or above 2 standard. That is 2S. Muhammad Radwan is asking me, I mean before establishing the new QC mean and standard deviation. For that, you don't need to compare between old lot and new lot. As I explained before, you should have 20 readings to establish the mean. And you can perform the control if you want, if you have a new quality control material and you don't have a QC provided, mean and SD provided by the manufacturer, or you want to establish your own mean and standard deviation. So you cannot process parallelly the old and the new QC just to maintain your work. You must process the QC material 20 times, and from there you can derive the mean. It can be on the same day. It need not be 20 separate days where you will, or 20 shifts to establish the mean and standard deviation. Yes, Laila has a question that, is there a need for lot-to-lot verification for the quality control? Lot-to-lot verification is done for the reagent, not for the quality control. A lot-to-lot verification is supposed to be done for new reagent, not for quality control material. Okay, is there any more questions?
There's no more questions. I think.
Thank you, Doctor, for nice lecture.
Thank you too. It's my pleasure, and I hope I have been clear in my explanations and my answers to the various questions. It was a pleasure speaking to everyone, and I hope it will benefit all of us to refresh our knowledge and widen our horizon. Thank you so much for giving me the opportunity to speak to this wide variety of audience. And you are welcome to ask me any more questions